Hello guys, so welcome to my channel. So today I am continuing my internship, that is Codesoft internship, and this is my task 2. So the task 2, this is my offer letter, Codesoft, and the task 2 was my movies prediction. I am stuck on the some code, some error I am getting, so I am continuing for the task 4. So the task 4 is sales prediction using Python, in which I have to predict the sales based on the forecasting, based on the marketing, advertising, TV, radio, newspaper, and all. So I have to predict the sales based on that data. So, so if you are new to the channel, please subscribe me. And if you want latest videos on data science or data science task or project or some learning videos, so comment me or suggest me so that I can make on those contents. So first we have to study the data, what the data is. And so this is the data. The data I am having is TV, radio, newspaper, and sales. So this is the data I am having, where how much amount is spent on the particular feature, that is TV, radio, newspaper, or sales, and our target variable would be sales. So for any data science project or data science task, we will first see the what is the problem statement or what is the objective. So we have to build a product which can predict the sales price of a product with respect factors, with the respect factors, that is TV, radio, and newspaper. Okay, so these are the steps required for any data science task or project. I have mentioned every time whenever I start any data science project. So this is a data gathering, where we have to gather the data. Then it comes to the data cleaning for handling missing values, duplicate records, outliers, and all. Data transformation, that is feature scaling, feature encoding, and feature engineering. Data integration, that is combining data from multiple sources. Data reduction and data normalization. Data splitting, which is model fitting, that is training and testing data. Data visualization and documentation. So I first run this code, that is a markdown code. Now have to first import the data set. That is, what is the data set I am having. One second. Yeah, what is the data set I am having? So yeah, so the data set I am having is advertising.csv, and the data frame, I have just called the data frame, and my data frame is taking time. Yeah, so this is my data set which is having TV, radio, newspaper, and sales. First I will check the info, what is the data frame info is there. So this is the info which is having 200 non-null values, means there are no missing values, and the data types are int and float. It's okay, we will describe the data then. So data set is having mean value of TV, that is 147, in radio, that is 23, newspaper, that is 30, and the target variable is 14. So here we can say that in TV it has been more invested than others, then comes newspaper, and then last comes radio. So TV, as we can say that TV is more used than newspaper and then radio. So yeah, it would be because radio is very old fashioned and no one listens it. Very few reads the newspaper and everybody watches TV. Now we check for missing values. There are no missing values. So we can move forward to duplicate records. Here also we are not finding any duplicates. So we will move forward to the outlier detection and treatment. So here I have called the distribution for KDE plot, which is having the kernel density estimation. Here I will check the distribution of the features of TV, newspaper, and radio, and I will check how the distribution is being done. So for checking the distribution, I will analyze that if the distribution is normal, means the data is okay and it's normally distributed. But if it's not, I have to transform the data because it will be having some outlier. So I will check it. and I've kept in a loop so that I can get in one time. So I am running this code, and it's taking time. Yeah. So okay, okay. So distribution of TV is somewhat having normal distribution, but it's not fully normal distribution. Distribution on newspaper is slightly left, and radio is somewhat fat. I don't think so. Means here we can say that distribution seems to be normal, but we will try different plots so that we can get a more accurate estimation. For example, box plot. So I am running box plot, and yes, newspaper is having some outlier. So we can say that there are outlier, but it's having only two, which does not affect our model because we will use a regression model, and regression model will not affect much while having outlier because it is not sensitive to outliers. So we will go for data transformation, and it does not seem that a data transformation is needed, but we will transform after model prediction so that we can compare that it's needed or not. So now we will move forward for model selection. So we can take a linear regression, random forest regressor, and SVR. So taking the columns as independent and dependent and classified. Then I will come to independent dependent variable. I am calling how it's looking. Now I am splitting the data into training and testing part, and then I am calling the libraries of linear regression, random forest classifier, SVR, and mean absolute percentage error, and I am creating an instance. Now I am keeping in the loop so that I can get my error, how much percentage I am having, and it's having 0.151, 0.120, and 0.050. As we had completed the prediction, now where we got our model random forest regressor works well, and mean square error is 0.05. Okay, means it's having very low error. Now what if we scale the feature and then we go on to the model fitting? The chances of getting model accuracy would be more or less. We will check that. So I had done the standard scaler for TV, newspaper, and radio so that it will be in the range of 0 to 1, -1 to 1. The range would be there. So the range, so the range would be 1 to 1, and I will see my new DF, that would be this, -1 to 1. So this is my range, and now I will check. Now we had scaled the data. Now we'll check how the model works, if it's accurate or not. So the new DF is this, and I am dropping the columns as same as the above. Same, we will be checking training and testing data. We will be splitting the data set, and we will go on to the model, importing the libraries for models. Then we will creating an instance, and then we will feed the data. That is, we are having. Okay, so here we can say that by scaling data, I got the mean percentage very similar to the ones which I predicted above. So our model works equally after scaling, and the model having the lowest error is random forest regressor having percentage error of 0.05. Means it's having similar only. So it's not so we can say that the before scaling and after scaling is having the same accuracy. So it's having no changes. So model this was my model, and if you now, okay, so this was my model for predicting the sales data. If you like this video, please share it to the friends about the data science task, internship, and all. Meet you to the next video, which would be about the iris flower classification. So means I have done this, that's why I am doing this iris flower classification, and after that I will be doing on the different internships because I want to complete this task as soon as possible. So, and this is my GitHub link. I also posted in my GitHub link, and you will find it in my description box. So, thank you.